Hey AS Math, the last video cut prematurely, but we're just going to continue with this guy right here. This behemoth of a problem. Again, refer to this page. This is the example number 6 from exercise 1D. This is getting equations. So not only are we going to sketch the lines, we're actually going to get the equations of our displacement time graphs. So get the gist, do not write all of it, and let's begin. Two cars drive along the same highway. One car starts at junction 1, traveling north at constant speed of 30 meters per second. We can also treat north as the positive displacement. The second car starts at junction 2, which is 3 kilometers north of junction 1, traveling south at a constant speed of 20 meters per second. Again, south we'll consider to be negative displacement. Part A, sketch the two graphs on the same axes. All right, so we're going to have two graphs just kind of coming together. B, find the equations of each graph. And then part C is solve the equations to find the time at which the cars pass each other. Hence, find the distance from junction 1 at which they pass. Never trust anyone who says hence, and hence let's begin. Okay. So part A, sketch the two graphs on the same axes. So let's start off actually making a graph like this, okay? Displacement versus time. Well, we know that junction 1 car, we don't really know where it's starting, but we can just assume it's starting at 0, honestly. All right, and now we know that it's just traveling at a constant speed of 30 meters per second. So the only information we know is the velocity of this guy, right? We know the slope. Not a big deal, not a horrible deal. Let's come back to that guy. The second car starts at junction 2, which is 3 kilometers north of junction 1. 3 kilometers. We typically like to work in meters, so that in meters would be 3,000, okay? So if you space your graph out, I space it out like this. I'll go 500, 1,000, 15, 2,000, 25, 3,000. Do 3,000 right there. And we'll call that junction 2. We'll call it J2. This is J1. All right. So now we want to see what they're going to look like. Well, I know that J1 has a slope of 30 meters per second. So what we can do is, let's see. Let's start with J2. Let's start with J2 for a second. I know it's starting there, and I know its constant speed is 20 meters per second, but it's going south. So we have a negative slope, okay? I want to figure out how long it's going to take for it to go from 3,000 meters down here to a 0 displacement, right? How long is that going to take? That would let me know how long I need to make my scale on my time. Well, I do know that if I'm going 3,000 meters, and I know that S equals VT, right? I do know that I can solve for the time by dividing both sides by V. So I'm going to divide this by my 30. Excuse me, by 20. That should be a 20 because we're starting with this distance. It's going at 20. I know that the time is going to be, if I divide these guys, I'm going to get 150 seconds. Okay? All right. So I know I need at least 150 seconds, okay? So if I go 50, maybe let's start with 20. 20, 40, 60, 80, 100, 120, 140, 160. So 150's sandwiched right there. And I know these points will be connected. And that's a way I can at least represent that, okay? Now the other one, again, I know my scale now. So I'm going to I know it's going to be steeper. So again, if I'm thinking about this, if I go, let's say I just go 100 seconds. So let's say this 140, 120, 100, just to kind of get the idea. If I go 100 seconds, my velocity is going to be 30, okay? What's my distance going to be? So I kind of know where to end up. It's going to be at 3,000. That's pretty sweet. So here, it's going to be right there. And I know I can connect those lines. Okay? So, little weird, right? But again, I'm kind of just using that reasoning to get the most accurate graph possible. So we're going to rock with this guy, and that is part A. Part B says, find the equations for each graph, okay? So let's go ahead and do that. I know there's straight lines, so they're going to be y equals mx plus b. So if they're y equals mx plus b, I'm not rocking with y, and I'm not rocking with x. This is s, and this is t, right? I actually want to do it like that. And I know my slope is going to be v, and my y-intercept is wherever I'm starting for my distance. It's the y-intercept. Well, if I start with car 1, which is junction 1, really, my y-intercept was 0, okay? So that one's nice, so I won't even have to worry about that guy. My velocity for it was 30 meters per second, so 30. And we're just trying to get the equation of this. We don't know what s and t are, but that's okay. I know S1 equals 30t. Maybe we do it 30t1. I don't know. Nah, we'll just call it 30t. Really does not matter in this case. I'm just going to call that S1. This guy right here, it did have a y-intercept. It did. Its y-intercept was 3,000. Okay? So I'm going to actually write this where b's over here. So this is 3,000. And I also know that my velocity was 20 meters per second going south, so it is negative, so this is minus 20t. And there are my two equations on my lines. And finally, part C tells me, find at which time that they cross each other, right? Okay, so it's looking about right there, but our graph's not perfect. This is probably the best way to do it. We know they're going to cross where their displacements are the same. So what I can do is, I can put 30t equal to, well, 3,000 minus 20t. Add my 20t over, 50t equals 3,000. And so we end up getting t equals 60 seconds. Okay, that is when they pass each other. All right, so good luck on your homework. There's only 3 problems, and I'll see you next week. Have a good weekend.